So if you haven't watched my previous video on how to prep a Damascus billet, stop this video right now and go watch that so that you understand how I prepped this ready for welding. But if you have, let's get into how we get started. To start with, what we need is a Damascus billet. Now this is a billet of file steel and file steel and spring steel. You can tell the file steel because I've left the teeth on the edges, and that actually just helped me get the correct layering count. So I've obviously got spring file, etc., etc. Now you can layer up whatever pattern you want. This isn't a patterning lesson. This is simply a forge welding lesson. So now that I've got my billet prepped, and say you'd prep your billet in a different way, once you've got your billet stacked, ready to rock and roll, the first thing you're going to need to do is flux it. Now, flux, for those people who don't know, is normally used is borax. There are some countries where you cannot get borax. I know that Germany and the UK, you find it very difficult to find borax. In that case, it's better to go with a corporate flux. There are a lot of companies that sell it. Iron Mountain sell it. And if you have no other option, that's a good way to go. It is a little bit more expensive, but it's incredibly reliable. This is borax that I bought from Bunnings, which is a local hardware store. Most local hardware stores will have it. In the US, I know a lot of shopping centers, Walmart and stuff like that sell it, so it's readily available. It is boric acid, but anhydrous. You want as little water in it as possible. Actually, to make this even better, you'd be better off to create a solution of borax and boil it down until it's completely dry, bake it in the sun for a couple of days, and then crumble it up, add a couple of iron filings, and that will just make it so much better. But if for this case we're using straight out of the store borax. This is just straight out of the tub that I bought it in. Now, when the steel is cold, the borax is not going to stick to it. So there are a couple of ways we can get it to stick to it before we stick it in the forge. Some people would argue that this step isn't necessary. Now that's true in that you can flux it when it's red hot. I prefer to flux it before I put it in the forge, so then I've already got some borax on it before I get welding. Now the couple of ways that I've used in the past are WD-40 and kerosene. Now unfortunately I don't have any kerosene, but what I do have is RP7, which is a WD-40 kind of fob off from Australia. It's got slightly more lubricant in it, which will probably make it an inhibitor a little bit, but it's not going to be too bad for it. So all we're going to do is give the Damascus a little spray. This is still hot from welding. I'm filming this on the same day that I filmed the prepping billet, but it doesn't matter if it's a little warm from weld. And all we're going to do is pre-flux it. Now you don't need to use a lot. There are people who kind of dump so much borax on it that, you can't see the billet for the white powder, but literally just a little sprinkle will do it. Now you can hear it sizzling, cooking onto the surface, and that little bit will mean that when it's coming up to that red temperature prior to our first flux, there will already be some borax inhibiting the scale that's being produced at heat. So now we're ready to stick this in the fire. But before I say that, I'm going to be forging in both gas and charcoal today, so make sure you watch the whole video through to get hints on how to use both gas and charcoal to get the proper weld. So the first weld we're going to do is we're going to be with the gas forge, and I'm going to be using a striker, my striker Mick, to do the welding, but you could do this by hand. There's nothing that stops you from doing this solo, and I'm going to do hand hammer forge welding on the charcoal forge. But the big thing about the gas forges is that you need to be able to tune them. And if you haven't watched my video on how to tune a gas forge, there is also a heat treating series that I've done, and in that I go into great detail on how to tune a gas forge. Basically want to tune this so that we're running a neutral atmosphere, which is a lot of gas and not a lot of air, but enough air that we're going to get that heat. And the reason for that is because the more neutral we can make the atmosphere, the less oxides we're going to be forming. The less oxides, the less inhibition to the weld. When I'm laying my billet in the fire, I want to face the side to the flame. If I've got a cylindrical forge and I've got more of a vortex going, then that's not so much of a point. But because I have direct flame, I want the billet to heat evenly. I'm going to flip back and forward. And the reason I'm putting it on its side is because that actually helps the borax slip between the between the layers of the Damascus. So we're going to put this in there, get it fired up, and get to welding. It's just starting to glow red. Very dull. That's when you want to flux first. The main reason you want to do it at such a low temperature is because at that temperature it's not developing scale. Much higher than that you start developing scale. But that's now ready to go back into the forge. So, as you can see when we were forge welding, what we were doing was, hitting in a pattern along the surface. Now, unfortunately, because we've only just started using the Mukazuchi, which is the Japanese sledgehammer, MIG still isn't quite tuned in, and the first image I showed was of a hit that was way too hard. Now, before we get into that, I just wanted to discuss the striking pattern on a piece of Damascus. Now, on these pieces of Damascus, especially using a large face hammer, the hammer face is about the same size as the Damascus billet. So we don't really need to worry about where we're hitting, except for the fact that our hammer face is slightly domed, and that's pretty standard for most blacksmith's hammers. So normally when I'm hitting a piece of Damascus, especially with a hand hammer, but even with a striker, we're going to aim to strike at the base near the handle first, and then we're going to follow up the center of the billet towards the toe. Then at that point we're going to turn, come down one side, go back up, and then down that side. I mean that probably started out. So that's your first blow there, and then that's your last blow out here. The reason for this is because you want to have a line of blows going down the center to first get that center stuck and get all of that borax smushed out of the piece. Then you want to close up your edges. The wider the piece, the more layers you may have to go. So you might do a line here, then a line, and then another line to get your edge. Because the last thing you want to do is forge your edges first, because what that does is then close in all of that borax inside the welding surface, and you'll never get a weld. Now, when you're striking Damascus, and this is the problem that we faced with that first billet, it was a very high billet, and it was made out of some very high carbon steel. Some leaf spring and file steel. So they're both fairly high carbon steels, and especially the leaf spring, which has a high chromium content, does not like to weld. So what happened was that Nick struck really hard at the base of the piece. And what that did was smush this area, but here hadn't been welded yet, and obviously my welds at the tip weren't quite up to snuff. And it sheared the weld by flicking that toe up. If anyone's ever put a piece of material over the edge of the anvil and hit near the anvil, you'll notice that the tip tries to flick up while the piece you're hitting goes down. That's exactly what happened here, is that end tried to kick up, whilst the piece that was in contact with the anvil wasn't under as much strain, so it just stayed where it was. Well, this is bent down, but actually, realistically, it's actually flipped the other way. So, basically, because he hit way too hard, and not with a pressing force, but more with a striking force, it caused that really big shear, and that busted the weld. And unfortunately, we didn't manage to salvage the top part of our billet. We have welded the bottom part of the billet, and that'll still be part of this series, but once that weld failed, scale developed in there, and no matter how much borax we put in there, we weren't going to consolidate that back into the piece. The other thing that can happen is the same problem that you get with this, but from the center. So when you're striking forces from the middle, if your hammer is coming down in here, especially if it's a narrow face on a large surface, you're going to end up putting too much force on the center of your billet, and the edges of your billet are going to kick up. With a Damascus billet, the steel is almost at a liquid state. You're getting close to that liquid state of steel. Especially if you're in a charcoal forge and you've got sparks flying, which we're going to show next. If you hit that really hard, what's going to happen is it's going to splay out everywhere. But the surfaces are the only thing that are liquid. So the center is quite hard. And if you hit it hard enough, then not only do you squirt out the borax, but you squirt out what little liquid steel there is. And that liquid steel is what you're actually aiming to stick. Which is why a lot of professional blacksmiths use hydraulic presses to weld their Damascus, because the hydraulic press simply squishes everything together. So when you're using a striker or when you're using a hammer, you want to be putting heavy but firm blows in. Rather than bouncing the hammer off the Damascus, you want to be pushing that hammer through the Damascus. There are a lot of people who say you want to tack weld lightly. That's good for very, very small billets, but larger billets, if you only tap it, then only the edges are going to get welded and that center is going to stay unwelded. So yeah, unfortunately, it was a little bit of a lack of experience on mixed part working with Damascus, and also a lack of experience for both of us with working with the Mukazuchi, which, it was both of our fault. We probably should have gone through a little bit of practice before we did this, but those are the things you need to keep an eye out for when forge welding Damascus as far as the hammer is concerned. We've got 2 billets welded up, we've got 1 more left. We're going to go out to the charcoal forge and get that welded up. So here we are at the charcoal forge. I have a small billet of Damascus, and this is small mainly because I don't want to spend all day hammering on this, but also because I have a small charcoal pot. Now, with charcoal, there are a few disadvantages, but there are a few advantages. The main disadvantage is that you're going to have inclusions and stuff like that wanting to get into your steel through charcoal dust. So there are a couple ways we're going to mitigate that. We'll cover that in a second. But the other disadvantage is the fact that you can overheat this really quickly and burn it. So when you're heating in a charcoal forge, a lot of people will naturally assume that the more air you give it, the hotter it gets, therefore the faster you can get to welding temperature and get it all over and done with. The problem with that is that steel, much like when you're heating anything else, if you're heating like a piece of chicken in the microwave, the outside's going to get hot before the inside does. And if you're heating this super fast, the outside will start sparking and burning before the center is even at a welding temperature. So even if you bring it out and it's throwing sparks and it looks fantastic and you hit it and sparks go everywhere, that does not mean that you're at welding temperature inside the middle of this, and that means you're going to have nothing but inclusions to deal with later. So especially when coming from cold, you want to work this up really slowly. You want to bring that air down as much as you can and slowly ramp the temperature up until it's just getting to that welding temperature. Now, when you're looking for a welding temperature in a charcoal forge, it's a little different when you're looking at it from a gas forge perspective. In a gas forge, you're almost never going to see sparks coming from the steel unless you've got a really, really efficient gas forge. Instead, you're going to be looking for that smoke coming off the steel, which is actually the borax boiling off. Otherwise, you're also looking for that borax bubbling like it's boiling butter in a frying pan on the surface of the steel. Unfortunately, I don't have a camera that's capable of catching that, but there are videos of it out there, and it's fairly easy to see. It's that really fast bubbling action. In a charcoal forge, you're not going to be able to see the billet most of the time when you're working it. So instead, there are a couple ways we can test. And the first way, and the one that I use the most, is to check for the presence of sparks. When you start getting small sparks coming out of the fire, not giant flail sparks, and you'll be able to tell the difference between steel sparks and the ash and the coal sparks that are coming out. You're going to want to pull it out and immediately go to the hammer and to the anvil and start smacking. And again, you're going to be careful about hitting it too hard. You don't want to bounce those sections apart. You also want to make sure that you're not hitting too soft and not actually getting the weld. So, as far as charcoal dust getting into the billet, you want to make sure, and unlike with the gas forge where you're putting it in sideways to help with that borax to seep through the layers, instead we're going to put it vertical, or we're going to have the layers going horizontally, so that we don't have the charcoal sitting directly over the openings to your to your Damascus, because otherwise you're going to get charcoal dust in there, and it's not going to weld. Because charcoal dust is just pure carbon, and it will just inhibit any weld that you put it in. So when I'm going to put this in the forge, I'm going to rake my coals back, push them off, put my Damascus billet in the forge, and then rake the hot coals back over before I turn the air on. And I'm going to make sure that I'm not sitting this directly in the tuya. I'm not sitting this directly in front of the air, because the more air that's on this, the faster it'll oxidize, which is going to mean a lot of burning and a lot of carbon loss. I want a layer of charcoal or coal, you could use the same thing in coal to fire, underneath and on top, because I don't want direct air on this. Now with that being said, other than that, all you're doing is heating this up and hitting it, and that's what we're going to get to now. So we're at that dull red heat. We're just going to lightly flux it. And I want to make sure that the flux bakes on before I stick it in the charcoal. Again, because the charcoal will brush off the borax. And that's pretty solidly welded, like that's all it takes. And you notice I was following that path round and up. Doesn't matter in which order you do it, but that's always a good way to start. Hey guys, thanks for watching the video. I hope you enjoyed it. I have a couple of notes before I jump off about forging Damascus. One of the very important things about using any kind of flux in the workshop is that it is dangerous to inhale. So please try and have a cross Febreze or do it outside, do it away from yourself. Don't directly inhale the fumes, even off borax. It can damage your internals, your lungs, stuff like that in large amounts. Obviously small amounts over, every now and again it's not going to hurt you, but if you're doing this consistently for a long periods of time, you're going to end up hurting yourself. So please keep care of yourself. The other thing is, it was mentioned in my comment section on the last video, the Damascus prep video, that there are a couple of people out there who do not prep their steel before forge welding, and it is true, you can get away with not doing a lot of the prep, but prep always makes better billets, and you'll always end up getting a better stick out of prepped billets rather than unprepped. And if you're using anything that has any kind of coating, then make sure you take that coating off, because the fumes from it can be very dangerous. So yeah, make sure you do that. But yeah, otherwise we have a nice bouquet of Damascus billets to play with now. We've already got plans for one of them, the file steel and mild steel. We've got plans to do something cool with this in the next couple of weeks, so keep your eyes out for that one. And the rest of them, I'm open to suggestions. We already have an idea of how many layers we want. We're actually going to marry up a couple of these billets to make kind of Sanmai, Damascus Sanmai kind of thing. But yeah, we're always willing to hear suggestions, so please feel free to fling us those in the comment section down below. If you want to support the channel, all you have to do is hit that like button and hit the subscribe button. And if you want to get notified about when I upload a new video, you can hit that bell notification icon. I upload a video every Wednesday. I also have live streams on Saturdays, and recently I've been doing a lot of deep dives on Fridays, which I hope to continue in the future. With that being said, I'd really like to thank my patrons, Jared, Nathan, Andy, Kine, Rich, and Braden. You guys are all fantastic people. You keep a hammer in my hand, gas in the tank. And if you want to join the Patreon crew, the links will be down in the description below. Make sure you go check that out. Otherwise, I'll see you in the next video. Thanks, guys.